and I will give very interesting topic. And my name is Ho Chang Chen. I'm from Taiwan, the master student of Department Forestry, National Zhongxin University. Today, I would like to talk about a quick screening method modeling the tree species spatial pattern using the DEN and the worldview to image data. If you have any question, I'm happy to answer your question after that section. And there are 5 parts in my presentation, which is from introduction to conclusion. So let's talk about today's topic. At the beginning, I would like to introducing a very essential tool for the forest management and the wildlife species conservation planning. Its name is Species Distribution Model that we call the SDM. This is a very promising method. It could help to design the conservation planning, the field survey, and explore the potential consequence of the climate change. So that's the model could integrate the 3S technology, greatly enhance the worker capacity, giving the ability to describe a pattern in natural over broader spatial scale and never before. So now we have new plan for to organize the data resource. We record the data by the GPS and broadly use the remote sensing data layer and totally input the GIS to analysis and the interpretation. Finally, we gather the prediction map and transfer to the 3D map for the policymaker to make decision. Well, even we have better than the traditional manner, it is still hard to describe species pattern accurately since we suffered many problems like species play very important role in the different modern resorts, and the different modeling have different modeling pattern. And more importantly, data quality, and we choose the predicted variable. Also, we need to consider, and that's the 2 points. And that study try to focus on that 4 points and to check the influence level. And the target species we choose from the central Taiwan, a widespread species, Chinese Goga tree, and that we call the CGT. CGT is a common species in Taiwan mountain, and it can grow in the broad and geographic environment space, so it's very popular in Taiwan mountain. And the second one species is a plum species. Its name is raised striped rhododendron, that we call the RSR. That species always form the pure forest and can grow in the acidic soil trace, and is specializing in the soil attributes. Because the 2 species have significant different species ecological root. That's why we want to use the 2 species to make a comparison. And the model will use the 3 model to predict the potential habit of single tree species. That's influence the maximum entropy model and the domain, and further use the biology model, since many literature and the other also recommend that's the 3 model. It's very popular in other cases. And the target, the study area, we orange from the central Taiwan. It's Huishun Forestation. It's a representative forest and very high resolution, very high resolution range, and very complex, the high biodiversity. And so far, we collect the sample from the Dongfeng watershed and the Guangdao watershed 2 sites. And by using the GPS, you can see it here. And then I'm going to talk about we want to talk at the end of the study at the 4 points we want to talk. First, evaluate the potential value by using the high resolution data or the satellite image data. And the test the different species trait is affect model performance. And the third one, assessing the ability of spatial extrapolation with model. And finally, we will determine the prediction model and which model are more useful for our modeling the resource. And then I'm going to talk about the flowchart in this study. And first, concerning the data correction, we collect the predicted variable layers and the species position layers. The topographic variable we use the DEN to generate, including elevation, slope, accept, terrain position, and the profile and the plane curvature. And we use the SPA5 and the WorldView 2 image to generate the NDVI. But we get some trouble when we use the WorldView 2. That's the high satellite image. Since the time limit, available data cannot control the data quality. And that's the picture to show you our pickup using the WorldView 2 image data. Because our study area is all the time have the cloud, so we cannot get no cloud and very clear the image. But we try our best. So next time maybe we'll attempt to use less than 10% the clouds for the image data. And besides, and this data, since the raw data, we only do the simple offender transformation. We do not to eliminate the geometric error because it's have the relief displacement. So next time we will do this. And the second, the species data obtained by the GPS and totally to do the post differential collection and could get very high accuracy. And total number, we get 113 sample for the CGD and 128 sample for the RSR species from the Dongfeng watershed. And the 60 for the sample for the CGD and the 61 for the sample for the RSR species collect from the other watershed, Guangdong watershed. And we combine those data points and to further to make sampling design. And that's pattern to show you. We spread the Dongfeng sample data. We randomly choose two sets of Dongfeng data for model development, and that we call the Dongfeng-based model. And the remaining sample we will use for independent test data. And the second design, we keep the Dongfeng-based model, but the test data taken far from another watershed, far from the Guangdong watershed place. The second become our second independent sample. And that's the design of series. We want to know what's the difference when the modeling only based from the Dongfeng. How about could expand to other place? We can test the model spatial extrapolation. And that's a slide to show you. We overlay 9 layers and input the species to clip suitable and non-suitable environment attribute data and totally input our model to model development. And the model development, we use the 3 model. Maxent is a promising new method for recently publication. Its core idea is using the entropy value and the probability distribution. That means it will give to every pixel a the probability value. And to find the uniform condition, and close to uniform, it means the natural forest, the distribution state. And the second, domain the model is using the point-to-point, the similarity metric. Its core idea is using the goal metric distance algorithm. So you can switch from the distance to the similarity matrix. And the third one, BioClean model, it's similar to the boxcar image classification. So we use the 3 model to predict our model, to predict the 2 species resource. And then finally, the result need to be comparison and the evaluation. And we use the independent test data from the Dongfeng and the Guangdong watershed. And we also use the kappa indicator to check the resource. Kappa considered by 5 level. When approaching the 1, that means the species observation and the predictor value have a good enough fit. And totally, no matter the development or the validation, we'll repeat 10 times to get the mean value and make model robust. And next part, we will talk our study result and the finding. And I prefer divide the 6 parts to talk my study results. That's including the evaluating the relative importance and of the predictors, and using the NDVI associated with the species extracted from the SPA5 image and the WorldView 2 image data, comparing the 2 species traits and the 3 model performance based on the SD1, and calculating the percentage of the potential high area. And also, of course, we will evaluate the spatial extrapolation with 3 models. Finally, I will show the example of the prediction map. And as mentioned before, the totally should be around 1,000 18 combinations. That's a large amount of calculating. So we try to reduce the data dimension and to help our calculating efficiency. And we follow the 3 models in the module. It could similar like the stepwise processing to pick up the variable relative high importance for the model. So we from the 9 predictor and we pick up top 3 the variable. And as you can see in the 2 species, elevation, slope, and the terrain position have a relative high importance for the model. So if we use the 3 predictor to build our Dongfeng best model, and that we call the combination 1, C1. And because we wish to try to compare when we added the spectral variable, what will happen? So we added the NDVI with the summer spot image and full spot image, and the high resolution data were from the worldview 2 image data. So later we call the C1, C2, C3, and C4. Next, I summarized that table to show you the C1 is using the Dongfeng best model. Is only the variable combination is only use the elevation, slope, and the terrain position. And it could be clearly seen that the C2 and C3 is not good for the widespread species and the RSR species. But when we use the high resolution data to generate NDVI, they intend to improve our model accuracy, but not significant since our worldview 2 image data is still the primary stage. So it's a raw data cannot predict very well. So I guess maybe in the next time we will test that's the point, can improve, that's the problem. And the second, we comparing the 2 species traits and the 3 model performance. Let's check the mean value. We can find, it could be clear that the right hand side, the mean value higher than the left hand side. So the species with the clone species, like the RSR species, could always predict very well higher than the widespread species. So that's point improve that if the species ecological route will significantly influence the modeling results. And further, we could check the top 2 choice, the model, Maxent and Domain were much better for the predicted widespread species, CGT, and the clone species, RSR2 species. And we also calculating the area percentage, and we find the Domain and the Maxent 2 model, they could reduce a high potential area for the 10% for the CGT and the 5% for the RSR2 species. That means if we further want to use the prediction map to make future investigation, they could save the cost level. So it's a large amount of workable useful information. And moreover, we to make a different sampling design, try to know the model could special extrapolation. And that picture should show you, that's the SD1 case far from the Dongfeng independent test data. SD2 is far from the Guangdao independent test data. And the 3 models have a similar change by the mean kappa value. When we increase the spatial pattern, they could decrease significantly, approaching the 0. That means if the model only based on the topographic variable, they only applied it within a limited geographic environment, but cannot over-predict the other watershed. So I also use the prediction map to show you an example. The map predict by a Maxent model, and we enlarge a local place and like the 2 red box line to show you in SD1 and SD2 cases what will happen for the difficulty for spatial extrapolation. Please see the check that's the prediction map. The orange color means the suitable happy, and the dark green is non-suitable happy. And the red and the sky blue point is our target species point. And we added the background non-suitable happy and to check in SD1 for the CGT cases. It could be clear since that the model can predict very well in the local area. But when we far from to other in Guangdao watershed, we could clearly see that the test data fall into the wrong place and cannot predict the collection. Other subspecies also have a similar phenomenon. We could say that in SD1 case, the model could distinguish very well the commission error, could reduce the commission error and the commission error. But when we see the other watershed, it total numbers it have this very serious problem and fall into the wrong prediction. Above the data result, I drew some conclusion. The first, the result exhibit that we primarily test the data results, and we find when we use the high resolution data, it might intend to improve our SDN modeling results, especially use the worldview to image data. And the second, the species trait were more influential on the SDN performance than the algorithms. And the third one, different model algorithms have different model results. And we first chose the maxent and domain were much better since they not only have a good performance and also could reduce the high potential area for widespread species or the clump species. And moreover, and the model if only based on the topographic variable, they only applied it within a limited geography without a significant error. But we try to over-predict the other place that will causing the mislinking and cannot predict very well. And finally, the study will still low some key factor not consideration. So in the future, we'll try to improve our data quality and adapt to the rate predictor or the other prox indicators. And also we'll use the high spatial resolution data and high spectral image data, which we could improve the local performance accuracy and further to make expand to a large area could fit. That's the model results. And that's my today's topic. Thank you for your attention.
Any questions?
Okay.
It's very interesting and it shows the results of the applications. And there are some errors from the application. You have analyzed the source of errors maybe from the data resolution, but I don't think so. You have take the topograph, the geographic information in consideration, but you miss something. For example, the geological information, the soil contents, and also the bedrock.
Soil.
Yeah, the soil and the bedrock have great influence on the specs. Okay.
Okay.
So, as the space time, you can use the geology methods to get to the integrated analysis.
Okay. Thank you, comment. Yes, actually, I have seen that's the point before. As I know, to growing the forest, they have 4 very important key factors. That's involving the topography, the soil, the climatic, of course, higher biotic interaction. But because our model is a primary stage, and we try to use the remote sensing, it's better than the traditional matter ecology surveyed. So topography is very useful and very quickly to generate from the DE and to generate elevation, slope, set, and so on. So it's very quickly and can keep stable the data quality. Maybe next time we will reduce the high potential area and we will go on site to set the data log to try to record the soil and the climate or microclimate. We will do this. Thank you for your comment.
Any more questions? Then we will conclude this morning session. And thanks to everyone for your attention, and also thanks to our 5 wonderful speakers.
Okay, thank you.